A person travels equal distances with speeds of 3 kilometers per hour, 4 kilometers per hour, and 5 kilometers per hour and takes a total time of 47 minutes. What is the total distance in kilometers? Well, it is certain that this distance is divided into 3 parts, and these parts are equal. Now let us assume that each part is x kilometers long. So the speed at which the first part is traveled is given as 3 kilometers per hour. The second part is traveled at 4 kilometers per hour, and the third part is traveled at 5 kilometers per hour. Right. So let us calculate how much time it takes to travel each part. For the first part, the time taken will be distance upon speed, that is x by 3. For the second part, the time will be x by 4, and that will be in hours, right? And the third part, the time will be x by 5 hours. Right. Now we have been given the total time it takes for this person to travel all the distances. So if we add up all of these times, you will get 47 minutes. But these times are in hours, so you'll have to convert 47 minutes into hours. Well, how do you convert it? Well, just divide it by 60. So 47 divided by 60. So on the left hand side you have, take the LCM of 3, 4 and 5, which is 60. 3 times 20 is 60, so 20x plus 4 times 15 is 60, so we have 15x, plus 5 times 12 is 60, so we have 12x, equals to 47 by 60. The 60 and this 60 gets cancelled out. We have 20 plus 15 is 35, plus 12 is 47, so 47x equals to 47. So we have x equals to 1, and this distance is in kilometers, right, because the speed was in kilometers per hour. So x is 1. We have been asked the total distance. What is the total distance? 3 times x. So 3 times x is equals to 3 times 1, and that's 3 kilometers. So option B is the correct answer. A farmer traveled a distance of 61 kilometers in 9 hours. He traveled partly on foot at the rate of 4 kilometers per hour and partly on bicycle at the rate of 9 kilometers per hour. What is the distance traveled on foot? So the farmer travels a distance of 61 kilometers in total. Now some part of this 61 kilometers he travels on foot and the rest of the part on bicycle. Let us consider that the part he traveled on foot be x, and the rest of the part that he traveled on bicycle will be obviously 61 minus x, and the unit will be kilometers, right? Now we have been given the speed of his travel on foot as 4 kilometers per hour and the speed of his travel on bicycle as 9 kilometers per hour. Let us calculate how much time it takes for him to travel by foot and travel by bicycle. So the time taken for travel by foot is actually distance upon speed, and that is x by 4. And the time taken for travel by bicycle is the distance upon speed, which is 61 minus x by 9. Now we have been given the total time of this travel, the complete travel, which is 9 hours. So if we add the respective times, we will get the total time, which is 9 hours. Now from this equation we can calculate x, which is the distance traveled on foot. On solving this equation, you get the value of x as 16. So 16 kilometers is the distance traveled on foot. Option C is the correct answer. A boy goes to his school from his house at a speed of 3 kilometers per hour and returns at a speed of 2 kilometers per hour. If he takes 5 hours in going and coming, what is the distance between his house and the school? Let us consider that the distance between the house and the boy's school is x kilometers. Now the total time taken for the boy to go to the school and come back, let it be t, which is equals to the time taken to go to the school plus the time taken to come from the school. Now the total time is given to us, which is 5 hours. So 5 is equals to time taken to go to the school Well, you know the formula for time, which is distance upon speed. The distance is x kilometers, so x upon the speed at which the boy goes to his school is 3 kilometers per hour. So by 3 plus again we have the distance as x upon the speed at which the boy comes from the school is 2 kilometers per hour. So by 2. So you have this equation, you can find out the value of x. So you have 5 is equals to 2x plus 3x by 6. This 6 goes to the left. You have 30 is equals to 3 plus 2 is 5x. So therefore x equals to 30 by 5, which is 6. So 6 kilometers is the distance between the house and the school. Option C. A man on tour travels first 160 kilometers at 64 kilometers per hour and the next 160 kilometers at 80 kilometers per hour. What is the average speed for the first 320 kilometers of the tour? So you have the distance of the total journey as 320 kilometers, and of that 320 kilometers, first 160 kilometers is traveled at 64 kilometers per hour and the next 160 kilometers are traveled at 80 kilometers per hour. Now what is asked is the average speed of the first 320 kilometers. Well, you know the formula for speed. Speed is equals to distance upon time. The distance is 320 kilometers. So 320 by the time. What time? This time is actually the time taken to cover the first 160 kilometers plus the time taken to cover the next 160 kilometers. So this is basically T1 plus T2. Now again you have 320 by what is T1? Well, you know the formula for time, which is distance upon speed. So the distance is 160 kilometers, so 160 by speed is 64 kilometers, so 64 plus you have again 160 by the speed is 80 kilometers, so 80. So this is equal to, you can take 160 by 16 common from it, so 320 by 160 by 16, what remains is 1 by 16 times 4 is 64 plus 1 by 16 times 5 is 80, so 5. So 16 times 10 is 160, this 0 and this 0 gets cancelled out. What remains is 32 by 1 by 4 plus 1 by 5. So it is 5 plus 4 by 5 4s are 20. So this is 32 times 20 by 5 plus 4 is 9. And that is equals to 640 by 9. Now you have to divide 640 by 9. Let's do that. So 71.11 kilometers per hour is the average speed of the first 320 kilometers. Now many a times people will take a simple average of the speed, but you cannot take that.